Hi, my name is Justin Lebrecq, and I'm a principal consulting engineer with MongoDB. Today, we're going to be talking about migrating to MongoDB Atlas, the what and how. First, a little bit of background on myself. I'm a consulting engineer with MongoDB and have been working with MongoDB in that capacity for about 4 years. That means that I've had a lot of experience migrating to Atlas from a variety of different customers, infrastructure, and topologies. So my goal today is to impart that knowledge to you and to provide some good insight into how to successfully migrate to Atlas. Now, we do have a few prerequisites, and these are prerequisites of the talk more than they are of migrating to Atlas. The prerequisites of this talk are that you've already decided to migrate to MongoDB Atlas. Atlas provides a lot of benefits, and we're not going to cover those benefits today. We're going to be assuming that you've already seen the benefits of Atlas and the migration path is something that you're willing to invest in. You've allocated resources to make a change. Any type of change requires resources. That is going to be people, and that's going to be time, it's going to be cost. Those resources are kind of a requirement in order to make any change, and migrating to Atlas is a change that you've decided to make. So there will be requirements to allocate resources to that. And finally, you've analyzed cost and come up with spending targets. That's going to be especially important when we start talking about the size of your Atlas cluster. So that's a good piece of information to have ahead of time because that will determine what size cluster you can choose when you fully migrate. There are some anti-goals. One, this talk is not going to provide you with step-by-step instructions. The MongoDB documentation provides thorough and very complete examples on how to migrate. So if you're looking for step-by-step instructions, please see the MongoDB documentation. Two, we will not be satisfying all environmental variables and solving every edge case. There are some very complicated scenarios when migrating to MongoDB Atlas. For example, I worked with a customer that needed to migrate multiple replica sets to a single replica set on Atlas. We were able to do it, but that's kind of an edge case that we're not going to talk about doing today. If you need help doing a more complicated migration, feel free to reach out to myself or professional services, and we can talk about how to make that happen. Three, we are not going to look at changes in your performance characteristics. You have a source and a target cluster, the target being MongoDB Atlas, and we're looking to get the same kind of performance characteristics in Atlas as you currently have. So let's jump right in. The first thing we're going to do is talk about the different steps involved in actually migrating. The first one is preparation. We're going to talk about things that you need to consider before beginning migration. We're going to talk about how to size your MongoDB cluster. We're going to talk about the actual migration process. What options do you have for making that migration? And then finally, we'll talk a little bit about the launch for this process called cutover. I'll define that later. The first thing we're going to talk about is preparation. So let's jump right in. The goal of a migration is to migrate with zero downtime. There are ways to migrate your data with downtime, but that's not an ideal scenario, and that's definitely not the goal of this talk. So the goal of this talk is to migrate with zero downtime, and I'm going to be making assumptions under that premise. So I encourage you to attempt to migrate with zero downtime. It works out best for most organizations to not have to send out messages to the users, to not have to halt activities on their systems, and we can accomplish zero downtime in almost every case. We need to define some terminology. So I'm going to define two terms right now. One is source. This is the source cluster, i.e. your current MongoDB cluster. It can either be a replica set or a sharded cluster, and it's inside your network or cloud environment. This is your self-hosted or cloud-hosted version of MongoDB that you are managing yourself. Finally, we have target. Your target cluster is your MongoDB Atlas cluster. This is the cluster hosted by MongoDB and managed by MongoDB. This is your Atlas cluster that you're migrating to. There are some basic requirements for using Atlas, and the first is that your application driver is current. Now, this is absolutely critical. I cannot stress enough how important it is that your application driver be up to date. I worked with a customer that had several different smaller applications that they were migrating to Atlas at the exact same time. One of those applications was legacy, and they forgot to check the application driver version. When they migrated to Atlas, that application ceased to function. The reason why is the driver was too old and didn't work with the version of MongoDB they migrated to. So the application driver has to speak the same language as your MongoDB cluster. If it's too old and it speaks a different language than the current version of MongoDB, the application will fail to function. So be sure to check your drivers and make sure that they are current. The source cluster must be a replica set. Now, this is a requirement for a no downtime migration. We do have tools called mongodump and mongorestore that I'll mention briefly that allow you to do a migration with downtime. But again, the goal of this talk is to have a no downtime migration. So to have that no downtime migration be successful, you have to have a replica set. Now, that replica set might be as small as a single node. So you can have a replica set of one node. It's much more common to have a replica set of 3 nodes, 5 nodes, 7 nodes, etc. But a replica set is required. That means configuring your MongoDB cluster to use replication, even if it's a replica set of one node. That is true of sharded clusters as well. Your sharded clusters do need to be replica sets on each individual shard in order for this to be successful. Also, the tools that we're using require that you use MongoDB version 2.6 or newer. Finally, you have to decide to make your life easier. Migration is going to be a little bit of work, but once you're fully migrated, the goal is to have Atlas help you out as much as possible. It should be easy to use. You should have metrics at your fingertips. We also have performance advisors that can help you make your administration easier, right? The goal of Atlas is to make things easier, and that's it, right? Those are all the requirements. The requirements for migrating are fairly simple. There are some questions that I advise that you ask yourself. These business requirements are internal questions that can answer or that the answers to will help in later stages of the migration process. So how much downtime can you tolerate? The goal again is to migrate with 0 downtime, but if you can tolerate downtime, it might just be easier to dump your data from your source and restore it into your target, right? That might require a lot of downtime depending on the size of your data. So we're not going to focus on that as an option, but you should ask yourself the question, how much downtime can you tolerate, if any? Can I change my connection string easily? I've worked with customers that compile the connection string into their application. That means that whenever they change their connection string, they have to redeploy the application, and that is a lot of work. Your connection string should be in something easily changed, like a configuration file, and it should be easy to reload. So instead of having to redeploy your entire application, it might be as simple as just restarting your application and it picks up the new connection string. We're changing to MongoDB Atlas, which means that the connection information will be different. Finally, what security restrictions are in place? Is my source cluster exposed to the internet, and can I allow external sources to connect to my source cluster? Security considerations are really important when choosing how to do your migration, so make sure to talk to your security team if you have one. Consider all the security implications of your migration because that will determine how it is that we migrate, so keep that information available for later. And that's it. That's all that we really need to consider when we're preparing. The next step is sizing, and we're going to jump right into that by first looking at compare. We're going to look at comparison, minimizing, and sizing. When we're talking about comparison, we're looking at the source cluster and we're comparing that to a target. In order to determine the size of your target, we need to figure out where to start. Well, to do that, we need to ask ourselves the questions. Are we optimizing for reads or writes? Most applications optimize for reads or writes. Most applications don't have an even distribution of 1. Are you currently provisioned well? Is your source cluster sized such that you can issue queries quickly? If your source cluster is undersized, then we don't want to have a similar sized target because that would mean that your Atlas cluster would also be undersized. Is your disk heavily used? One of the biggest problems that I find out in the field when working with customers is that customers rely too heavily on their disk. Disk is the slowest part of a computer. Therefore, queries that have to access disk will be slow. It's just A to B equals C, right? You go to disk is slow, your queries will be slow. So if your disk is heavily used, we want to avoid heavy disk usage when we migrate to Atlas, and that might require upsizing your cluster. Finally, does your source cluster have measurements? Do you have metrics that you can use in order to properly size your MongoDB Atlas cluster? If you do not have metrics, I recommend that you look at Cloud Manager or Ops Manager. Ops Manager is the on-prem version of Cloud Manager, which is hosted by MongoDB. Cloud Manager will record metrics in a secure and safe way from your source cluster for any extended period of time, and you can use those metrics to very intelligently determine the size of your Atlas cluster. Minimize. What is minimize? First, minimize is the idea that we're trying to save you some cost. You could just migrate to an M100 or 400, which generally takes any kind of workload you throw at it. It's a large enough system that any type of workload will be successful. But cost is generally a factor for most organizations. So choosing a super large cluster can be very costly. When we talk about minimizing, we're talking about choosing a smaller cluster size to save cost. When we talk about cluster size, we're always talking about memory. Memory is one of the biggest factors in whether or not you'll succeed in your migration, because if you size your cluster too small, that means your queries will need to go to disk and your queries will be slow. I always get asked the question, what about IOPS? Aren't IOPS important? And we're going to talk a little bit about that in a second. So let's define some terminology. We have memory. All database operations must be performed from memory. This is not a MongoDB thing. This is a database and computing thing. In order for computers to process information, that information has to be in memory. It gets pulled from disk, stored in memory, and then the CPU works with that information in memory. Memory is critical for good database performance. This is true of all databases. Whenever you query something, the information to satisfy that query must be in memory. It is also the most expensive part of your hardware. The more memory that you add, the higher your cost. Generally linear. As you add additional memory, your cost increases linearly up to a point. At a certain point, if you add too much memory, your cost starts to increase exponentially. Disk IOPS. A disk IOP stands for input-output operations per second. It's a very convenient measurement for cloud providers. It is inconvenient for human beings, and you really shouldn't care about it. Really, honestly, seriously. I get people asking about disk IOPS and how they relate to cluster sizing all the time. You shouldn't care about it, and this is why. We're going to compare disk IOPS to transfer rate. A disk IOP is a measurement of operations per second, but who can tell me what constitutes an operation? I would guarantee that anybody listening would not be able to tell me what constitutes an operation. It's a non-repeatable measurement because operations differ for different workloads. There's a maximum IOPS set by your cloud provider. It's a great way for cloud providers to measure how much you owe because they can measure how many operations are passing through their wire. But it's not a great way to actually size a cluster because you can't really relate it to how busy your cluster actually is. What we really care about is your transfer rate. This is the measurement of kilobytes per second, megabytes per second, or gigabytes per second that you're reading from your disk. This is measurable and repeatable. So for a workload, you will consistently see the same transfer rate. For that exact same workload, your disk IOPS can be wildly different. The maximum is set by the hardware, and it is great for measuring how much you're reading from disk. How do you increase the transfer rate? You add IOPS. How do you add IOPS? You increase your cost. So let's continue down this path. If we're talking about minimizing your cost, and memory is the most expensive part of your infrastructure, how do you determine how much memory you have? Well, the memory required should be the total size of your indexes plus the size of your working set uncompressed. An index is defined as a sorted list. Indexes exist to make queries fast, they are compressed, and they are easy to measure. MongoDB provides this statistic so you can easily determine the size of your indexes by looking at your source cluster. The working set is the set of data actively used. It changes based on the active behavior of your application, and it is difficult to measure. My example for this is tax records. In the United States, you are required to save 7 years worth of tax records. So you might have 7 years worth of data, but generally speaking, you're not always looking at 7 years worth of tax records. You might only be looking at the last 2 years. So because you're only querying 2 years of tax records, your working set is 2 years. How do we determine the size of our index? Well, I have a script that will do this for you. It's on the screen. You can see that this script iterates through every database and every collection, records the total number of indexes as well as the size of those indexes, and outputs that on your screen. I've done one of the two components for your sizing. How many indexes do you have? How much memory does that require on your source cluster? So let's dig a little bit deeper into this idea of keeping your indexes in memory and sizing for your indexes. In order for an index to be fast, it must be in memory. Well, what does that actually mean? right? If you have an index, again, it's a sorted list and it exists to make your queries fast. If that index is on disk, it kind of defeats the purpose of having an index, right? Just like an index in a book. You go to an index in a book to find things that you're looking for. Well, if your index is on disk and your data is on disk, that means that you're going to disk twice as often, and that defeats the purpose of having an index in the first place. So it must be in memory. If we're looking at your memory, we have OS, we have WireTiger cache, and something called file system cache. The reason that WireTiger generally takes 50% minus 1 gigabyte is beyond the scope of this conversation, but WireTiger does take 50% minus 1 gigabyte by default. I don't recommend that you change that unless you understand why it takes 50% minus 1 gigabyte. If we examine what's actually happening within that WireTiger cache, we have our indexes plus our working set, plus something called an eviction threshold. What we care about is that 80% eviction threshold. Again, that is beyond the scope of this talk, but when we're looking at the size of our indexes, we need to figure out how much memory we actually need given an index. So I'll give you an example. If you have 32 gigabytes of total RAM, your WireTiger cache is 15 gigabytes. From that 15 gigabytes, we take 80%, and that means that the maximum size of our allowable indexes is going to be 12 gigabytes. We've already measured the size of our indexes. Therefore, if those indexes fit into 12 gigabytes, we have a properly sized system. If they do not, we need a larger set of memory. You can do the exact same thing in reverse. If you have the total size of your indexes, divide by 0.8, and then you get your RAM maximum by multiplying by 2 and adding 1 gigabyte. So if we have 8 gigabytes of indexes, dividing by 0.8 is 10 gigabytes. Again, divide that by 0.5 and add 1. That makes it 21 gigabytes. Generally speaking, cloud providers don't sell 21 gigabyte machines, so we round up and we get a 32 gigabyte machine for 8 gigabytes of indexes. So let's spend time looking at your indexes. Indexes are very, very important. So you want to make sure that you understand what indexes you use. Before you migrate, it's important to remove unused indexes. As you can see, memory is the most expensive part of your system, and the more indexes that you have, the more memory that you need. So removing unused indexes is a really helpful way to minimize your cost. Also consolidate indexes. There's a rule of thumb when choosing how to order compound indexes called ESR, equality sort range. This is beyond the scope of this talk, but if you have a lot of indexes, it's easy to remove some of those indexes by consolidating certain fields. So for example, if you have an index on A and an index on B and an index A comma B, you probably don't need the index on A. It's a duplicate. There's more information about this on the MongoDB documentation, and we can also go through this through the MongoDB University by looking at one of the courses discussing query optimization. The goal here, however, is to minimize your memory requirements before performing any sort of migration. Again, that will reduce your costs. So how do we actually choose your size? Well, we've now determined how much memory you need for your indexes, and we've rounded up. That rounding up should give us enough memory for hopefully our working set. But again, because the working set is hard to calculate, at a minimum, we need to determine the size of a cluster based on our indexes. From that, we're given a set of tiers. That set of tiers tells us how much RAM is available to us. Based on that RAM, you determine what size do you need based on your indexes. Fairly simple from there. The prerequisite here is your cost target. Ultimately, when you're determining the size of your cluster, we want to be within your cost target, but we also want good performance. If you know the minimum size cluster for your workload based on your indexes, and you know your cost target, if you exceed your cost target, it's time to go reevaluate your indexes to make your cost target smaller. Conversely, if your application is well optimized and you aren't hitting your cost target, it's time to go reevaluate your cost target. Because at the very minimum, to have a successfully issued migration, you need a properly sized cluster. Now for a replica set, you do the math on your indexes and you get the size cluster you need. For a sharded cluster, you pick an instance size and then you do some math. A sharded cluster means that you have multiple shards that host all of your data. So the total size of your indexes will be larger than one machine will probably be able to hold. So how do you figure out how many shards you have? Well, you probably have a certain number of shards at your source cluster. Given that, you can either use that same number of shards and then doing some math, you can determine how much RAM you need based on that number of shards. Or if you don't have a replica set at your source, then a sharded cluster at your source rather, then you can determine your size by picking an instance size and then determining how many shards you need from there. So you can go from either direction. Most of the time, you're migrating from n shards to n shards, right? The same number of shards on your source and your target. That is the most supported method of migration. Therefore, in order to figure out the sizing, you figure out the size of your indexes and you divide by the number of shards in your cluster. For production, upsize by 1 or 2 tiers. Minimize risk, this is production. One of the great benefits of Atlas is that you can downsize your cluster very simply. If we're trying to minimize risk, which in a production environment we are, it makes sense to spend a little bit more money by upsizing your cluster for a period of time. If you upsize your cluster before your migration, migrate faster because you have a larger cluster. Your cluster can ingest data faster, and then release your product with this new larger cluster. You'll be able to measure successfully whether or not that cluster size is oversized, right? Again, based on the indexes and based on how often you go to disk. Once you determine that the oversized cluster is providing too much power, you can then very quickly downsize. Downsizing is one click of a button, and then you go from, say, an M60 to an M40 very, very easily. Use your metrics to determine what size and when you can downsize. So now that we've determined our sizing, we can actually look at our migration options. This is the major part of the migration process, is actually moving your data, and we have a few options when it comes to that. Do you want an easy migration? Yes, use Live Migration. Live Migration is hosted by Atlas, and it's the easiest and most straightforward way to migrate. When I'm working with customers, I advise them to use Live Migration whenever possible. This slide is a little bit of an exaggeration because easy, no, alternate migration path. Other migration paths are not hard, they just require more work. So if you meet the requirements to perform a live migration, I recommend that you use MongoDB Atlas Live Migration. These are our options for migrating to MongoDB Atlas. We have Atlas Live Migration, mongomirror, and mongodump and mongorestore. I'm going to talk a lot about mongomirror in just a bit. We're first going to talk about live migration. First off, how do you choose whether or not you can use live migration? Well, there are some prerequisites for using live migration. All nodes in a cluster must be accessible and DNS resolvable. If you're using internal DNS, live migration will not succeed. There are issues with resolving your internal cluster names across the internet. The goal of live migration is to have your MongoDB Atlas cluster connect to your source cluster. Therefore, if you cannot resolve the names of your source cluster from the internet, then MongoDB Atlas will have issues connecting. That also means that you need to whitelist certain IP addresses. Atlas will provide you with a list of IP addresses that you can whitelist so Atlas can connect directly to your source cluster. Your source cluster, your MongoDB cluster, should be behind a firewall, and in order to allow access from the cloud provider, you need to add those IPs to your firewall as part of your whitelist. Your source and target versions must be compatible for migration. I'm going to provide you with a list of different versions and what are compatible or what not, but in order for live migration to be successful, your versions must be compatible. If all of those can be met, I suggest you use live migration. Live migration offers the easiest and most robust way of performing your migration. It is the preferred methodology, so I recommend you take a serious look at satisfying those requirements. But let's say that you don't satisfy those requirements. We have another migration path. We have things like private networks or VPCs. If you have a VPC that is not connected to the internet, live migration cannot connect to that VPC. Therefore, you must use a different migration path. If you have firewall restrictions, for example, if you cannot provide a firewall a port opening or whitelist to allow external connections into your network, you must use a different migration path. Similar for versions. If you have a compatible version, you can use live migration. However, there are cases where you have a version mismatch between your source cluster and your MongoDB Atlas target. If there is a version mismatch, you can use mongomirror to perform your migration. mongomirror provides more control of the process. It also provides more control of your timelines. However, it does require self-hosting. I'll mention this again later, but in order to run mongomirror, you need a node dedicated to run mongomirror, and it must be within your VPC. So there is additional cost incurred by running mongomirror. MongoDB Atlas Live Migration has a few more requirements. The version requirements we'll talk about in just a bit. Network access for Atlas, we talked about that earlier. You also have to have certain permissions available on your source cluster. You need the cluster monitor and read any database role provided to the user that Atlas will use to connect to your source cluster. So let's pretend that I'm creating a user called migration. That migration user on your source cluster must have cluster monitor and read any database as roles in order for the migration to succeed. If you are using a self-signed certificate for SSL within your source cluster, you need to provide the CA or certificate authority to Atlas. You should be able to find that in your configuration of MongoDB on your source cluster. So that should be something that you can easily get. Also, MongoDB Atlas gives you a 72-hour time period before requiring a cutover. We'll talk more about cutover later, but Atlas will only give you 72 hours before you are forced to migrate your application to begin using Atlas. Now, you can extend that period by 24 hours every day. However, if you begin your extension on a Friday, that means that you also have to come back and extend it another 24 hours on Saturday and again on Sunday in order to perform a migration on Monday. So just be aware that Atlas will give you 72 hours and that may be extended. We have some version requirements. If you have a replica set, you can migrate from version 2.6 to version 3.64 or 4.2. I'm not going to go through each of these versions, but if you have a replica set, generally speaking, you can migrate to any of the versions available on MongoDB Atlas without any issue. Sharded clusters have more stringent version requirements. For example, if you are migrating from version 3.6, you must migrate to Atlas on version 3.6. Same with 4.0 and same with 4.2. You cannot migrate from version 3.6 to 4.2 on Atlas. Live migration will prevent you from doing that. There are ways of migrating with a sharded cluster from mixed versions. You must use mongomirror, and we'll go into that a little bit later. This is how you migrate with Atlas Live Migration. If you have a cluster, you click on the ... of your cluster and you click migrate data to this cluster. You'll be presented with a screen that provides you with IP addresses. That IP address is what you need to add to your whitelist on your firewall. Your cluster, again, must be internet accessible. You can provide a username and password if authorization and authentication are enabled on your source cluster. And then again, SSL if you provide a custom CA. mongomirror is a utility that is provided by MongoDB for migration. It's available for you to download, and it's available for you to run on your self-hosted machine. It's a utility that has different requirements than live migration. First off, you must have a dedicated machine to run mongomirror. I've worked with customers that try to run mongomirror on the same cluster as their source MongoDB cluster, and it ends up conflicting with resources. If you think about what has to happen, mongomirror has to query every single collection to copy the data to MongoDB Atlas. Because of that, the resources required will be conflicting with the MongoDB process. So host mongomirror on its own individual machine. Source cluster requirements, supported version and upgrade path. The required version is at least version 2.6. Connectivity to the Atlas cluster via internet or VPC peering. If you're using Atlas, you can enable VPC peering, and that means that your data will never traverse the internet. If you use VPC peering, you can run mongomirror inside of your own cluster and have it connect to Atlas without connecting via the internet. Similarly, your source cluster still needs cluster monitor and read any database roles. These are the replica set versions that you can migrate for with MongoMirror. 3.6 is the minimum version because that's the minimum version that Atlas currently supports. MongoMirror does not support sharded clusters. If you cannot use a sharded cluster, or if you have a sharded cluster that is an older version that must use MongoMirror, you need to contact MongoDB professional services or support in order to get help migrating a sharded cluster. Again, I strongly recommend that you use live migration if you're doing a sharded cluster. So what does this topology actually look like? Well, we have nodes. Those are your MongoDB nodes inside of your network, and then you have Atlas. Similarly, if you're using MongoMirror, you have, again, your nodes and MongoDB, MongoMirror, but MongoMirror is running inside of your network. The actual data transition comes in this direction. So with live migration, the live migration process is connecting to your nodes, to your MongoDB cluster, and copying the data in that direction. If you are hosting MongoDB MongoMirror, then your network is dialing out to MongoDB Atlas and pushing the data outward. So we've talked a little bit about the requirements for live migration. When do you use MongoMirror? Use MongoMirror when VPC peering is required, when security prevents incoming connections, i.e. you can't have live migration connect into your cluster, or if you require longer cutover periods. Again, 72 hours is the maximum amount of time that Atlas will allow you to use live migration if you do not extend it 24-hour periods more. You can continually extend the period 24 hours, but that requires manual intervention. If you know that you're going to have a longer cutover period, then MongoMirror makes a lot of sense. And again, run MongoMirror on a dedicated machine. I've had many organizations that I've worked with fail because they're running MongoMirror and they're having resource conflict problems. Now, I do need to talk very briefly about mongodump and mongorestore. This is the fail-safe option. If you can't choose one of the other options because of security or complexity, you can always use mongodump and mongorestore. It is the slowest option and has the highest storage requirements. In order for you to use mongodump, you need to read all of your data and then write it to a file, and then use mongorestore. You read that file and write it to your MongoDB Atlas cluster. It does require downtime because things can't be changing once you do the data dump. Any changes that happen after the data dump will not be copied over to MongoDB Atlas. It does work with every version and every topology. If you're using MongoDump with a sharded cluster, connect that MongoDump instance to the MongoS. If you're using a replica set, connect it to your primary MongoD. So finally, we get to the last step, which is your cutover. First off, what is a cutover? The cutover is your official switch from your source to your target cluster. We're finalizing the data stream via a one-way sync. It is absolutely critical to remember that migration is a one-way sync. Once your application begins writing to the target cluster, your source cluster is no longer valid. This is very critical because if you do not change your entire application to migrate at the same time, it's possible that you get what's called a split brain problem where you have data that differs on two different clusters. You prevent that by preventing writes to your source cluster once you do your cutover. The easiest way to do that is by shutting down your MongoDB cluster at your source when you're ready to perform your cluster. If you do not do that, there are no guarantees about the consistency of your data. Consistency of your data leads to the question, do we validate? Validation is optional based on your business requirements. Validation is based entirely on your internal level of confidence. Now, there are different ways of doing validation. Different organizations do different things. The simplest way to do a validation is to do a db.collection.count on all of your different collections. It's the simplest way to validate, and it also provides you the lowest confidence. It doesn't tell you anything about whether or not individual documents differ. If your count is the same, that might be enough confidence for your organization. A simple but more time-consuming method of checking your data is to run a db hash. Run the db hash on your source and your target, and then you can compare the results. The problem with this is if your data is changing because we're doing a no downtime migration, then your db hash might be inaccurate. Data changes on your destination cluster, therefore the hash will differ. So this would require additional time and might require downtime. You can do an all document comparison. It's very rare that I see this actually done, but you can compare every single document on your source and your destination to verify that they are the same. This is very time consuming. And again, if your application is online, you can have false positives. The most common is random sampling of comparison, or actually rather, if you're doing document comparison, the most common is random sampling of your documents. Choose a number of random samples, work through your data randomly, and compare. The most common method of validation is actually to not do validation at all. When I work with customers, most customers do not validate after they migrate their data. MongoDB does a lot of these. The tools involved in the migration have been very fully vetted. So most organizations trust that as their data is migrated over, that everything will be migrated successfully. However, if you do need a simple type of validation, the most common is to do a count. If there is a requirement to compare individual documents, the most common is to do a random sampling of documents. So finally, we're going to talk a little bit about what this looks like. You can see down at the bottom of the screen, we have in-process migration. Once you start live migration, the initialization process begins. This is what it looks like as it's copying data. You can see that it tells you how much data has been copied and how much data total should exist. Once your copy is done, you see a timeline. In my case, I have 71 hours of 72 hours total left. You can extend that time by clicking the Extend Time button. Next to that, you see a green minute and second indicator. That is how far behind your target is from your source. You can continue making changes on your source cluster, and those will be synchronized to your target cluster. If the number rises above 0, that means that your target cluster is behind. You must wait until that number is 0 before performing your cutover. Otherwise, your data will not match between your source and your destination. If you want to extend your time, this is what that dialog looks like. You can click Extend Time and then confirm. Once you are fully satisfied and you have done your validation or whatever processes you need in order to perform your cutover, i.e. changing your connection strings, then you can actually perform your migration. Clicking on the Migrate Data button will provide you with this dialog. It provides some information as well as some basic connection strings. You can see that one of the requirements in that process is to restart your application, update your connection string. The connection string is provided for you on the screen. And then once you have restarted your application, you can click the Cutover button. Cutover means that the live migration process will terminate. So when you're restarting your application can begin talking to the target Atlas cluster without having any issues because the Atlas cluster is online and is accepting reads and writes. The cutover will stop the synchronization. And this is what mongomirror looks like. When you run mongomirror, you can see that you have to provide a series of parameters, and those parameters will connect to the source and the destination, and it will begin copying data. This is what the copy data looks like. So you are given in progress updates as that data copies. I do recommend running the mongomirror process in a screen or tmux in case your session gets disconnected. That allows you to revisit the session at any time without terminating the mongomirror process. So your data gets copied over. It does happen in parallel, so it is a fairly fast process. Depending on the size of your data, it might take more or less time. Once your data finishes copying, we then go through a series of synchronizations, and then we build your indexes. Index builds can take a lot of time depending on the size of your data. There will not be progress updates as those indexes build. The mongomirror process has not stalled. You're just not getting progress updates because the MongoDB process is building your indexes. Once that's complete, we synchronize the source cluster to the destination. If it takes you 24 hours to prepare before you cut over, you can leave mongomirror running for 24 hours, and you can see the difference in seconds between the data on your source versus the data on your target. And then finally, we have a few gotchas that happen with mongomirror. I see these gotchas all the time. Customers have issues running mongomirror. The first one is avoid non-alphanumeric characters. That is true of your username and your password. What I often see is that alphanumeric characters like non-alphanumeric characters like exclamation points or hash signs cause problems with Bash. So when you're running mongomirror, you must put your password in the command line, and that means that bash might interfere with your ability to authenticate. Now, the second gotcha is your password will be visible in the command line. So I recommend that you create a user specific for the purpose of migration, and you remove that user after migration is completed. That password will be stored in your bash history. So be aware that your cluster will be less secure while mongomirror is running. Use host names, not SRV connection strings. When you're configuring mongomirror, you have to put in a source and destination cluster. The destination cluster connection string by default is given to you from Atlas as an SRV connection string. I recommend that you use host names and not SRV. The way that you get that connection string is by choosing an older version of MongoDB when you click the connect button within your cluster screen. Index builds may take a long time and there are no status updates. Don't worry, it's not stuck. I mentioned that just a bit ago. It can take a while for indexes to build. And finally, migration may be resumed after oplog entries are applied. mongomirror can terminate after the first few steps have completed. Once it starts saying the difference between your source and destination cluster is 0 seconds or 10 seconds or whatever that number might be, you can terminate mongomirror and resume mongomirror at a later period of time. How long you have to resume depends on the size of your oplog. That's beyond the scope of this talk, but do keep in mind that you can resume. Finally, once you've run live migration or mongomirror or mongodump and mongorestore, your data will be in your target cluster. So we have successfully migrated to MongoDB Atlas. Now, I know that there has been a lot of information covered in this talk, so I did want to leave you with a few resources. The live migration documentation as well as the mongomirror documentation is very thorough. If you do decide to run with mongomirror and would like to download a copy, it's at the link provided on your screen under mongomirror. Now, we didn't have an opportunity to talk about every possible migration strategy. So if you do have additional questions, feel free to contact me or MongoDB Consulting Services, and we'd be happy to discuss different migration options with you. Otherwise, thank you for attending my talk. I hope that I've helped you determine how to do your migration, the what and how. Have a great rest of your afternoon.